All right, hi guys. It's Mr. Ivan here, like always, if you're watching this video. So today I'm gonna do a quick review of this PDF of system of linear equations and cover the intro to substitution. So, as I mentioned here, obviously this is really complex if you're still kind of struggling with finding x and all those inverse operation rules. So we're just gonna walk through it first. First, we're gonna define what a linear equation is. Basically, a statement of like 2x plus 4y equals 10. The equals 10 here is probably the most important part because it's saying that it equals 10 is what makes this an equation. Okay? An expression would just be something like 2x plus 4y, right? So this. The equation is because we know what it equals, or we know it equals something. And then obviously you guys learn inequalities in 7th grade. That's when there's a greater than or less than sign or equal to. So as I mentioned here, right, the x and the y are variables in the problem, and then the 2 and 4 are coefficients. Okay, if you ever need vocab on your tutorials, you could probably use those if you're using these problems. There's also the words system of linear equations, right? You have to define them. So if you notice, each one individually is a linear equation, and then when we have two paired up together like this, we now get a system of linear equations. Okay, so if you're confused on why that ever matters, basically what they want you to do is figure out the values of x and y to make both of the systems true. Okay, so if you're looking at this problem right here, you need to find out what works for y on the bottom, right, and on the top. And sometimes there might be a tricky solution involving fractions and all that, but that's why we do it. So we're going to be going off this one first in our example, right? That's what this entire PDF begins with. So we're going to look at x plus y equals 3, right? Now you can tell me right off the bat that, oh, x can be 3 and y is 0, but then I'm going to tell you to check it into our other equation. So this is the second equation in our system, right? And looking off that second one, I'm assuming that x is 3 and y is 0. So now that I look at it, I'm substituting x, okay? And all substituting means is you take the number, so in this case, x is equal to 3, and you plug it in for x. You can see that right there. It's written in blue, right? Instead of x, we're putting 3 there. So then you're forced to multiply. That's the operation that goes there. And the same thing for y is equal to 0. Instead of 4y, we have 4 times 0 because we're saying that y is equal to 0. Now, if you notice, if you assume that, you get 6 plus 0, and 6 does not equal 10. Now, this told us that this statement right here needs to equal 10. That's why we know that's not a solution for this system of linear equations. And I highlight that here, right? This isn't a solution. Now, you might know what it is by looking at it. It is a pretty simple system, but we're going to walk through it, right? So the solution needs to work for both systems. So just because y as 3 and x as 0 might work here, if it doesn't work up here, then that's not the solution to our system. And that's what our job is, okay? Our job is to find it. There's two methods. One of them is the method of substitution. The other one is the method of elimination, okay? In this video, we're going to cover method of substitution. So if you notice, I use the word substitute right here. That's kind of foreshadowing what we're forced to do when we do these problems, but let's walk through into the intro of it. So first, let's define it, right? Substitution, oh, sorry. I'm going to leave it at the bottom. Substitution requires one of the variables to be known, so we can substitute our known variable to find the unknown. Now, that's just my definition of it. It might be a little tricky to figure out, but what I mean by that is like this statement right here saying x is equal to 5 plus y, that's a known variable. So even though we don't know what y is, I know that x is always equal to 5 plus y. And the same applies over here, right? We have y is equal to 7 minus x. It's, while there might be a variable in that statement, it is telling you that y is equal to that always. And that means we know what y is, right? If I give you these two statements and I ask you what is x, you should be able to tell me x is equal to 5 plus y. If I ask what y is, you should tell me that y is equal to 7 minus x. So that's why I have these highlighted here, right? So they're telling us what x or y equal, even though there's still another variable involved, right? As you can see here, there's still a variable in these two statements. We know what the other one is. We know what x is and we know what y is. So knowing that, you can actually substitute and start solving. So let's start getting into that, right? We're revisiting the initial system. It's the same one we've been working with. So we have 2x plus 4y is equal to 10. We have y plus x is equal to 3. You should notice neither of these tell us what x or y is equal to, right? They tell us that y plus x is equal to 3. Tell us that 2x plus 4y is equal to 10. But they don't say anything like y is equal to this or x is equal to this. So I already have it highlighted here. But that means we can rearrange, okay? This is probably the trickiest part to recognize. If you don't understand this, then substitution might be a little bit difficult. So what I mean by this is you take one of the systems you were given, okay, and you rearrange them to tell you what y is equal to or to tell you what x is equal to. Now, if you take a look at our first system right here, this one, ideally, you're not going to rearrange one that has coefficients in front of the variables, okay? Sometimes you're forced to do stuff like that. There's no other option. But we're going to look at this one specifically, and that's why it's highlighted here in red, because this one has no coefficients, okay? It's just the variables. That means I can easily rearrange this linear equation to tell me what a variable is equal to, right? And I highlight that here. No coefficients makes this a lot easier. Oh, sorry, my highlighting's a little off today. So let's go and see what I mean. So we're not touching this one, okay? We're rearranging y plus x is equal to 3. Now I'm gonna take that statement, y plus x is equal to 3, and I'm going to move the x or move the y so I can get a statement in the format of x equals something or y equals something, right? In this case, we're going to be trying x first. So if you're confused on what I mean by rearrange, it's as simple as this. You set up as if you were going to solve, okay? I notice that I have a y and an x on this side, and that equals 3. So because I want to know what x is, I'm going to move my y by subtracting it. And obviously, whatever I do on one side, I have to do the other. And I subtract on this side, and I rearranged it, okay? My y, if you notice, is no longer on the left side, but it's over here on the right side. And that gives me the statement of x is equal to 3 minus y. Now, if you notice, that's the format we want, okay? We want a statement that says x equals something. And in our case, it's x is equal to 3 minus y. So if you notice here, I have it let's rearrange for y as well. If you could, please pause the video and do your best attempt. You're trying to get a statement that says y equals this, right? So, if you just watch me do it, you're not going to learn as much. So obviously, we start with this original statement of y plus x is equal to 3. And I'm trying to get rid of the x. So I'm going to get rid of it on the left side and move it to the right side. I'm left with y after I subtract my x's is equal to 3 minus x. I rearrange the equation, right? Keep in mind that y is equal to 3x is the same thing as y plus x is equal to 3. It's just rearranged, okay? So from our original statement of y plus x equals 3, we know that x is equal to 3 minus y and y is equal to 3 minus x. You notice we have two questions in the format that we want, right? Of x equals or y equals. We now know what those variables are. So now we can finally substitute and solve this problem, okay? So we're gonna move on to performing substitution, okay? So the first step is to rearrange, and we just did that, okay? So when you see this solution right here, we rearrange to find these two variables. Next, you can substitute into the equation you didn't rearrange. So what I mean by that is I'm gonna number these real quick. There's equation 1 and equation 2, okay? We messed with equation 2 to get these statements of, get these statements over here, right? Those came from equation 2. So when we take these to substitute, we're going to substitute them into this. 2x plus 4y is equal to 10. Sorry if you guys can hear all the Can-Ams that are driving around. The Saturday afternoon, so that's usually when they're out. So we're going to look at this one, okay? We're going to substitute either x or y into this equation. So if you notice on my step 3, I'm actually going to be substituting x is equal to 3 minus y. I would appreciate if you guys pause here and do your best to substitute y is equal to 3 minus x, right? And see if you can get the result. So I'm going to substitute x is equal to 3 minus y into 2x plus 4y is equal to 10. Now, by substitute, we are replacing what we know x to be, which in this case is 3 minus y, into where the x used to be, okay? So, oh, sorry, I can always do. So note that we replaced x with what x equaled, okay? I didn't just throw in x is equal to 3 minus y. That would defeat the entire purpose, and that's also wrong, okay? When you substitute what you know the variable is equal to. I know that x is equal to 3 minus y. That's why it's 3 minus y that got substituted. If you notice, I didn't touch anything on the other variable. I still don't know what y is. But now that we only have y's in the equation, we can actually solve for it. So if you notice, by replacing x, now we have 3 minus y and 4y. There's only one variable in this equation. We can start solving for it, okay? Obviously, you're going to distribute. That's what's being highlighted here. So you distribute. This will give you 6 minus 2y plus 4y is equal to 10. So the very next thing is to combine like terms. That's a very big step. We see it every tutorial. And all that's left after you combine like terms, you'll get a statement like this. 6 plus 2y is equal to 10, okay? You have to find y through inverse operations, okay? Now, some of you guys are still a little confused on this, but you're basically just removing everything around the variable until you get what the variable equals. So on this left side, we have 6 plus 2y. I don't need that 6 there, okay? I'm trying to get to y. So I'm going to get rid of it by doing the opposite. Because it's adding, I'm going to subtract, and whatever I do to one side, I do the other. After I subtract, that leaves me with 2y is equal to 4. Oh, sorry. I made a typo right there. It's not 2y is equal to 4y. It's actually incorrect. It's just 2y is equal to 4. Right? I added a variable there if you caught that mistake. So now that I have that, I get this statement 2y is equal to 4. 2y implies that the coefficient is multiplying, right? So I divide. The coefficient here is 2. I'm dividing by 2. That gets rid of it. It's technically a 1 there, but it's redundant to write it, okay? So whatever I do to one side, I do the other. And that gives you this statement. Y is equal to 2. Now, we did just do a lot of work. These problems are long, but unfortunately, we're not done there. I know that might pain some of you guys to do more than, a few calculations. So now that we know what y is, you take that and plug it in for y to solve what x is. Now, you can note that you can do this with either equation, okay? Earlier, I mentioned that whatever equation you rearrange has to be plugged into the other one, okay? Once you solve for something, once you get a statement like y equals 2, right? Like the known number, you can plug it into either or. So in this case, I'm going to plug y is equal to 2 into this equation of y plus x is equal to 3, right? Because it's easier. There's a lot less numbers in there. So we solve. Now, obviously, 2 plus 1 is equal to 3, so it kind of gives away what x is. But we're going to follow all the algebraic rules. I'm going to subtract 2 on one side, and because I did it on one side, I have to do to the other. And that leaves me with x is equal to 1. Obviously, you guys knew that. But now, you found that x is equal to 1 and y is equal to 2. If you notice, I wrote here, for the system of linear equations, 2x plus 4y is equal to 10, and y plus x is equal to 3, the solutions are 1 is what x is, and y is equal to 2. What that means is that these numbers here will work for both. And if you notice, that's true. Because oh, that's my eraser. Unlucky. If you notice, 2 times 1 is 2. 4 times 2 is 8. 2 plus 8 does equal 10. That's good. Y is 2. X is 1. 2 plus 1 does equal 3. It's not like before where it only worked for one equation. So that substitution, I try to keep it as short as possible, so I kind of rush through this. That's just my explanation of how it works and kind of explaining the PDF. If you're wondering what the point of this is, you go to Desmos. These are our graphs. If you notice over here, 2x plus 4y is equal to 10, y plus x is equal to 3. If you notice, the point where these two lines meet, right, is 1 and 2. X is 1 and y is 2. That's the solution for these, okay? So basically what you guys just found is where these two linear lines intersect, okay? That's why we do these things. So these points over here are where they're crossing the x and y axis, right? But if you notice, the red line is one of our equations, the blue line is the other. And where these lines meet happens to be x is equal to 1 and y is equal to 2. Now if I go back to what we found, those are the same exact coordinates we found for our equations. So that's what substitution is, okay? As I mentioned earlier, I mentioned it up here. There is a method of elimination, okay? This is what you have to do when substituting doesn't work. So if you know when substituting doesn't work, I'll give you guys extra points. I wouldn't expect you guys to, all right? I know some of you guys barely covered this. If you're in McGaughy's class, you went over it a decent amount. But that's how substitution works. Okay, that's my best job of explaining it. If you have any more questions, you can find me in the tutoring room, or sorry, in Mrs. Hickey's room at lunch. There's plenty of tutors that would be willing to help you, or just chat, honestly, as long as you're working on something school related. I hope you guys are having a great day, and I'll do my best to explain elimination as fast as possible. And don't forget to do your headings in pen. Don't forget you guys have binder checks on Monday.